Hello students, welcome to the today's session. Welcome to today's session. So today is the 21st day. So let us continue our crash course of 45 days. Our today's chapter will be P block. So we will see upon the theory part first of all. Then we will move to questions. So with that, let us move to the theory part of today's chapter, which is P block. Before that, we have a short disclaimer here. The disclaimer says that the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in the slide deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. So what are the topics that we are going to cover today? First of all, we are going to see the introduction part, right? So we will see some basic introduction. What is P block element? Why are they called so? Then next, periodicity and properties of P block. We will relate the say properties of P block with the long form of or the modern form of periodic table. Moving on further, we have properties of their hydrides. Then we will specially learn about the boron thing. Okay, so boron is very important member of this family, which is our say group 13 element. And then we will look upon its preparation properties and uses. And at last, we will also look upon the aluminium. Okay, we will look there what are the preparation properties and uses of aluminium also. So first of all, let us move to the introduction part. So what is p block element? So basically in the p block element, what happens at the last electron enters in the outermost p orbital. Okay, so this is the way we can define whether a given compound is p block or not. Okay, so a given element is p block or not by deciding that whether their valence electron is going to which substance orbital. So if it is going to the p orbital, we call it as p block element. Now there are 6 groups of p block elements in the periodic table. So we are starting from 13 and moving on to 18, right? So the electronic configuration goes in the similar fashion. We are starting from ns1 ns2 to np1 to 6. Okay, so 1 to 6 means we have 1 2 3 4 total 6, so that is 13 to 18. So you can just get the thing that why we are saying from 1 to 6, because from 13 to 18 we will have the electrons to p orbitals. After that the p orbital will be completely filled and the next electron will go to d orbital. Now helium is not in that uh, section, although it is falling in the 18th group, but still it is not in that p block element because its last electron is going to s orbital. Its configuration is 1s2. Okay, so its last electron is going to the s orbital of the first shell. Next thing is the effective nuclear charge from first period to third period decreases, and from fourth period on fourth period and onward increases. So what is the meaning of this? So first of all, why it is decreasing? Because of the incoming orbital in between, right? So there are orbitals in between that interrupts the interaction between the electron and proton. But later on, we have a d orbital, and d orbital is very diffused in shape. Means diffused means it is scattered. So if you look at the structure of this d orbital, you will find that it is this same electron density is being dispersed over a larger area. So that results in a smaller shielding effect and hence a greater say effective nuclear charge. Now since ns2 electron is bonded closely to the nucleus because it is present in s orbital, and s orbital has the highest penetration effect because its shape is spherical. For that reason it is much more attracted symmetrically towards the towards your nucleus or the nucleons that are present inside it. So therefore the oxidation state 2 unit less than the group oxidation state become the progressive more stable in each group. So what is the meaning of this? So as we will see that for some elements the oxidation state is reduced by 2. And what is the reason? The reason is the inertness of this ns electron, and that thing is called as inert pair effect. So why does it get inert? Because the effective nuclear charge, as I have told you, increases down the group because of the poor shielding effect of the d orbital, and as a result your ns electrons are attracted very firmly towards the nucleus, and they are difficult to be removed, so this oxidation state become almost inactive for this higher elements, and this is called as inert pair effect. moving on further Moving on further, non-metals and metalloid exists only in the p block of the periodic table. On moving down a group, metallic character increases and non-metallic character decreases. What is the meaning of this? So non-metal and metalloids exist only in the p block. Okay, so if you look at the p block, the non-metals and metal exist only there. If you see the d block, then most of them are what are metals. In the s block, most of them are metals, because they are alkali metals and alkaline earth metals. And similar thing can be said for the f block element. But in the case of your p block, we have this metals as well as metalloids. So metalloids are what? So they are the elements whose properties are in between of metals and non-metals. And when you move from up to down, so down a group, then the metallic character increases. What is the reason behind it? Because the size is increasing. So the electron that are more attracted or more attracted towards the nucleus, basically they are now moving away from the nucleus, and since our electrostatic force of attraction is totally dependent upon the distance and charge, and the charge and your distance is increasing and the in relation is inverse, for that reason we see that electrons are easily removed and therefore its metallic character decreases, and the reverse of that can be said for the period because the size is decreasing. Now second period element have a tendency to form p pi multiple bonds, okay, due to their smaller atomic size and high bond energy. Okay, what are the examples of it? The example are C triple bond C, which is our carbon triple bond carbon. So a carbon has the unique property of forming this multiple bonds and forming long chains and all. Right, same goes for this carbon double bond carbon, then nitrogen triple bond nitrogen, oxygen, and this carbon dioxide. So all of this, you can see in all of this that as you are seeing the elements that are present in the lower section of the means the p block, which have the lower atomic number, they all have a greater tendency to form this p pi bonding. Okay, so this is a very important point, you should remember this. Now whereas elements of second period do not expand their covalency due to their unavailability of d orbital. So what is being said here is that, so if you look at compounds like BCl3 or CCl4, they cannot expand their covalency, means they cannot accept electrons. Okay, they cannot accept electrons. As a result of it, their oxidation number cannot be reduced further, and the main reason behind it is the unavailability of the d orbital, which we see in the later on periods. While elements of the third period like your phosphorus, sulfur, aluminium, they all have a vacant d orbital where they can accept electron and where their oxidation number can go up to -6. Okay, sorry, yeah, -6 also in some cases. Now next, non-metal oxides are acidic or neutral, and metal oxides are basic. So you must have studied these things in your primary in your previous classes also. This is a very usual concept which says that your non-metal oxides, whenever your oxides are from non-metals like the carbon dioxide or carbon monoxide, they all are acidic or neutral in nature. Whereas your metallic oxide, suppose your ferric oxide or your copper cuprous oxide, say all of these are what very basic in nature, because in that case your metal is there which has a tendency to lose electrons, right? And that has been passed on to the oxygen, which now in turn has a tendency to give electrons. As a result of it, their basic character increases, whereas in non-metals the opposite case is seen. And what about metalloids? So metalloids are amphoteric in nature. Amphoteric means they show both acidic and basic property. Now if you move from left to right, the acidic character increases because your size is decreasing and now it can accept electron due to the uh, approximation or proximity towards the nucleus, right? Now basic character increases down a group. Again the same reason, size is increasing, so it can easily lose the electron because of the small electrostatic force of attraction. Now generally oxides with a higher oxidation state are more acidic. Why is it so? Because higher oxidation state means, suppose if chromium is in +5 or +7, then it has a greater positive charge. Therefore, it will have a greater tendency to accept electrons, because positive charge attracts negative charge. That is the basics behind your electrostats, and that same logic is being applied here. Next is basic character of p block hydrides decreases on moving down a group, and acidic character increases. Generally, left to right in a period, acidic character increases. So just keep that thing of hydride to oxygen also, you will get the point. A very simple point to understand. So suppose you have NH3, you have pH3 and your ASH3. Then NH3 is the most basic one, then we have the pH3, and then we have the ASH3. Clear? Okay. So this series is very very important. Questions are often asked from this series, that you compare the basicity of this, right? So children make mistake because they think that nitrogen is more electronegative. So for that reason, their basic character would be decreased, but the opposite is seen here. And the inert pair effect is the main reason behind the basicity series that we are seeing here. Similarly, from left to right, if you move, so this is down the group, this is left to right. Then also your NH3 has the greatest basicity, then your H2O, and then your HF. Whereas the thermal stability decreases. Why it decreases? Because of the bond length. So when you are moving from top to bottom, the bond length is increasing, so the thermal stability is decreasing down the group. Whereas the thermal stability of hydride decreases down the group, due to which the tendency to act as a reducing agent also increases. So if it is thermally less stable, that means that the hydride that is attached to the non-metal is very easily available for donation. And as a result of it, this hydride can be used to reduce various compounds. Clear? So for that reason, their reducing power is increasing. Now, what about the properties of hydrides? So first of all, the bond angle. So if your central atom is more electronegative, then the bond angle will be more, because in this case, what happens? Your lone pair that are available, they are more attracted towards the nucleus because of the greater electronegativity. Now that creates a repulsion, and as a result of it, the bonded pair electron moves further away. Okay, so this same thing can be said for the bond pair also. So when oxygen is present, the bonded electrons comes closer to the oxygen, and that creates a repulsion, and hence the hydrogen move far away. Clear? So next we have sulfur, which is less electronegative than oxygen, and then we have selenium. Moving on further, so if you are moving from carbon to nitrogen to oxygen, that is across the period, then you see that the bond angle is decreasing. Why is it so? Again, it is due to the electronegativity. So when you move from left to right, the electronegativity of the element is increasing. As a result, the bonded pair are more towards the nucleus, and to minimize the repulsion, on the basis of Vesper, we can easily say that the hydrogen bond means the hydrogen bonded electrons are pushed away from each other. Clear? At the same time, the second most important reason, I would say the dominating one, is that we have a lone pair. Now that lone pair is pushing the thing inward. Okay. So these two are opposite of each other. First of all, the oxygen is collecting the electron from the bonded pair. That creates a repulsion. So that should have increased the bond angle. But due to the greater number of lone pair, which is a absolute negative charge, because in this case a bonded electron, maybe it may be like attracted towards the nucleus, but still it is being in the influence of the hydrogen. But the lone pair are completely on the nitrogen or on oxygen, and their repulsion, their strength of repulsion is also greater. We know that lone pair bond pair repulsion is more than the bond pair repulsion. For that reason, we have a smaller bond angle. Clear? Next is boiling point of hydride. So boiling point of hydride is expected to be increasing from top to bottom because of the greater van der Waals radii. But there are some anomalies, and the anomalies are due to the hydrogen bonding in case of HF, H2O, or NH3, because they are involved in the intermolecular hydrogen bonding. Okay, and hydrogen bonded molecules are miss hydrogen bonding forces are stronger than the van der Waals forces. Next, we have unique behavior of the first element in each group. So it is due to the small size and high electronegativity and non-availability of d orbital that in the valence shell of first element in each group is seen. So what is the meaning of this? So basically the first element in each group have a unique property as compared to the element that are present in the rest of the group. What is the reason behind it? The reason behind it is the small size. So basically all of these chemical properties na totally dependent upon the चार्ज इज टू रेडियस. सो दैट थिंग इज इम्पोर्टेंट. तो इसके कारण से क्या होता है कि चार्ज और अगर चार्ज और रेडियस का रेशियो अगर सेम होता है तो वो दोनों जो एलिमेंट्स होते हैं उनकी प्रॉपर्टीज भी मैच करती है. अब क्योंकि जो हमारे पास जो एलिमेंट है ऊपर वाले सीरीज में वो बहुत ही छोटे होते हैं, इसलिए उनका चार्ज इज टू साइज रेशियो बहुत ही वेरी करता है इन कंपैरिजन टू द डाउन एलिमेंट्स दैट वी हैव. क्लियर? ओके, मूविंग ऑन फर्दर. फर्दर वी हैव, सो वो कौन कौन से एलिमेंट्स है? दोज एलिमेंट्स आर बोरोन, एल्युमिनियम, गैलियम, इंडियम, थैलियम. सो दिस आर द मेंबर्स ऑफ ग्रुप 13. सो द बोरोन एलिमेंट इज deviating from rest of the members. Okay, so we see that it is a non-metal. ठीक है, this is a non-metal and the rest of this are metals. So you can see that although they are falling in the same group but they are having different property, and that is only for the boron because of its small size. So if you look upon the electronic configuration, so this is the electronic configuration ns2 np1. So it is hydrogen, helium, lithium, beryllium. So 4 electrons. Okay, so this is the ground state and this is the excited state. So this is for boron. Clear? Now next, so the oxidation state, the stability of +3 oxidation state decreases down the group and that of +1 increases down the group, and that is due to the inert pair effect. We know it, we have studied it already, that as we move down the group, so the NH3 then PH3, then as we more moving down, the s orbital electrons are attracted, are being pulled inward, and as a result they are becoming slowly and slowly inert and they don't take part in the reaction. Clear? So as a result of it, the +3 oxidation state become less and less obvious and +1 oxidation state dominates. Now fourth period onward, effective nuclear charge increases due to the poor shielding effect. Therefore, the radius of the gallium and that of aluminium on moving down the group inert pair increases. Okay, so what it is being written here, that the radius of gallium is less than of the aluminium, and the reason is what? The reason is the means occurrence of d orbital, because now we have the d orbital which has a poor shielding effect, and as a result of that we will see that the outermost shell are attracted more strongly and the size of the atom contracts, and hence we can see that we have a what? We have a smaller size, and on moving down the group the inert pair effect increases. So we have seen it already, we have discussed it in terms of the oxidation state. Next is our hydride. So if you talk about the boron hydride, so they exist as dimeric or polymeric form. So simple boron hydride is diboron. Okay, so this is diboron, whereas the aluminum form one colorless solid polymeric hydride which is AlH3n, known as alane. So remember this formula. So these formulas are very important, and also their properties. Sometimes questions are asked based on their properties, like there is an element having, sorry, there is a compound having say solid colorless structure and all, and in this way they frame this question and student do get confused because of the um, less information about the structure and all. Now the hydrides of gallium and indium are not stable, whereas they are much more whereas boron and aluminum and gallium are forming complexive ion like NaBH4. We know it is a reducing agent, similar LiLH4 and LiGHF4. All are what? Strong reducing agent, because their hydrides are not stable and they quickly donate hydride and reduce the other elements. Next we talk about halides. So halides of this say boron is having an incomplete octet, which is this. So see, we have an incomplete octet of each of this. Now the acidic character is increasing. So first Vi3, then BBr3, then BCl3 and BF3. Now one would say that okay, now fluorine is attracting electrons, so they must have reduced the electron density on boron. So the acidity of boron should be increasing. but it is not the case. So what is the reason behind it? The reason behind it is a back bonding. The lone pairs that are present on fluorine, they are being back donated to the boron, and as a result of that, we see that boron becomes electron rich. And why is this seen only in BF3? So see, it is seen in case of every halogen, but since boron and fluorine, they are in the same period, as a result, their overlapping is much more efficient as compared to the other compounds that we are seeing, or as compared to the other boron halides that we are seeing. If I talk about the physical properties, so BF3 is colorless gas, where BCl3 is colorless fuming liquid, while Bi3 is a white fusible solid. And due to the back bonding and resonance, so the same thing is written. The BF bond of BF3 get a bond order of 1.33. So since it is back donating, it is creating a partial bond, and as a result of it, we see that we are having a smaller acidic character than the ideal case. Now talking about the oxides, so the basic character of oxides increases. So BO23 is weakly acidic, where Al2O3 is amphoteric. Why? Because of the size. Size is increasing, and that is the only reason that we have. At the same time, the availability of d orbital and all changes this thing, right? Because the d orbital is being present, right? So the properties do get changed, and that creates a lot of you can say complications in the properties of the elements as you move down the group. If you talk about the important mineral of boron, then they are borax and orthoboric acid and kernite. So just remember all these formulas, this is very important. And if you talk about the preparation, so they are prepared by electrolysis of fused mixture containing boric hydride, magnesium oxide and magnesium fluoride at 1100 degrees Celsius. So suppose MgO is first of all heated, so that gives us Mg plus O2. Now MgO acts as a reducing agent and it reduces boron to 2b. Further, the crystalline boron that is obtained by the reduction of B2O3 with aluminum powder, it is treated with aluminum powder, and that thing is giving us again a reduced boron. So the both of this reaction, we are getting a reduced boron. So in this case also the amorphous boron of low purity is called motion is obtained and it is black in color. So in this case your purity is low, and that boron is called as a Moisen boron and it is black in color. If you talk about the physical properties, so boron exists as an allotrope. So we know that there are many allotropes of say carbon. Similarly, there is existence of many allotropes of boron also. So examples are amorphous and crystalline. So crystalline boron is chemically inert, while amorphous boron is chemically active. Okay, and it is a bad conductor of heat, and it is obvious that why it is a bad conductor of heat, because of the less disordered say structure. Now next is chemical properties. So amorphous boron on heating at 700 degrees Celsius forms mixtures of oxides and nitrides. So this can be shown with this reaction. So these reactions are very important for you. Just try to remember these reactions. Now boron is attacked by oxidizing agents like H2SO4 and HNO3, and they can be oxidized to H3BO3, which is a boric acid. And it also dissolves in fused alkalis and liberates hydrogen. We can see Na3BO3 is formed, and it also liberates hydrogen when dissolved in alkali like NaOH. Next we have, it reacts with strong electropositive elements to form borides such as Mg3B2. So simple reaction, and it happens at high temperature, and this is a very strong reducing agent. So 3CO2 plus 4B gives us BO23 again. Again SiO2 and 4B gives B2O3 again. So you can see how in multiple forms you can form your B2O3, that is your boric oxide. And it is used as a controlled rods in atomic reactors and a deoxidizer. So it's a very important reaction, right? So this is used in atomic reactor as a control rods. Okay. At the same time, it is a deoxidizer because it is reacting with the oxygen to form their oxides. Now moving on to the properties of aluminium. So the important ores of aluminium are AlOX, OH 3 minus 2x, first this one, where x goes from 0 to 1, and we have kaolinite, which is Al2OH whole 4, Si2O5. It is also an ore of aluminium. So if you talk about the preparation, so first of all let us take bauxite contain SiO2, right? iron oxides and titanium oxide as impurities. So these are present in the bauxite. Now leaching of bauxite is carried out with NaOH. Right, the aluminium is obtained by the electrolysis of the Al2O3. First, if it is leached with the help of NaOH, and then we are treating it with Al2O3. Okay, so not Al2O3 is obtained. So we are electrolyzing this Al2O3, that is the obtained Al2O3, to get the Al and oxygen as well. If you talk about the physical properties, so it is bluish white lustrous metal and loses its luster due to the formation of protective oxide film Al2O3, and it is light, malleable, ductile, good conductor of electricity. We know all about it. It has much more properties of a metal, although it forms amphoteric oxides. Okay, so this was all for the theory lecture today. Thank you. So let us see the question that are related to the today's theory. So first of all, questions session will be there will be questions there, and you will given some time to solve this question. Right, so just try to solve them within time. If you don't, then we will give the solution also. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this slide deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. Moving on to the index. So as usual, so we have 9 questions and all. They all will be multiple choice questions, and you have some time to solve them. So there is the timer against each question. So let's start our today's session of questions. Question number 1. Boric acid is called acid because its options are: A, contains repressible H plus ions; B, gives up a proton; C, accepts OH minus from water releasing proton, combines with proton form water molecule. So you have 30 seconds to solve this question. Your time starts now. Okay, so your time is up. Let us see the solution. So the question was that boric acid is called acid because its molecule. So first of all, the answer is that it accepts OH minus because there is no H plus present in the boric acid that is available to be donated. Right. So what it does, that due to the small size, it attracts the lone pair that is present on the oxygen and that is being attached to the boron that we have. Clear? So that creates a negative charge on boron. On the same age, it creates the role of the what? It creates the role of accepting species, which is your accepting a OH minus. Clear? So this option, the correct option would be C. Now moving on to the next question. Question number 2. So heating of an aqueous solution of aluminum chloride to dryness will give. Your options are: A, AlOH Cl2; B, Al2O3; C, Al2Cl6; D, AlCl3. You have 30 seconds to solve this question. Your time starts now. So your time is up. Let us see the solution. So what we are heating here, it is heating an aqueous solution of aluminum chloride. ठीक है? So suppose आपके पास Al2, the answer would be Al2O3, right? So suppose you have your AlCl3 and you are heating it in the presence of H2O. So due to hydrolysis, it will give what? It will give you AlOH whole thrice plus 3HCl. Now if you heat it, then you will get what? So जैसे ही इसे हम हीट करते हैं तो इससे हमें क्या मिल जाता है? Al2O3 मिल जाता है, ठीक है, और 3H2O मिल जाता है. तो ओवरऑल रिएक्शन आप इन दोनों को अगर ऐड करोगे तो आपका फाइनल इक्वेशन आपको मिलेगा, ठीक है. सो योर करेक्ट आंसर वुड बी बी. ठीक है, मूविंग ऑन टू द नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 3. बोरॉन कैन नॉट फॉर्म विच वन ऑफ द फॉलोइंग एनायंस. योर ऑप्शंस आर BF6 3 माइनस, BH4 माइनस, BOH4 माइनस एंड BO2 माइनस. सो आपके पास इस क्वेश्चन को सॉल्व करने के लिए 30 सेकेंड्स है. योर टाइम स्टार्ट्स नाउ. तो योर टाइम इज अप नाउ. अब चलो सॉल्यूशन देखते हैं. सो क्वेश्चन था कि बोरॉन जो है वो कौन से एनायंस इनमें से नहीं फॉर्म कर सकता. सो योर करेक्ट आंसर इज BF6 3 माइनस. ये ऑब्वियस है, ठीक है, क्योंकि BF अगर आप बोरॉन की बात करें तो उसके पास अगर एक्साइटेशन के बाद भी आप देखोगे तो सिर्फ और सिर्फ क्या है, एक वैकेंट ऑर्बिटल प्रेजेंट हो रहा है ना. और इस वैकेंट ऑर्बिटल में आप 6 फ्लोरीन एटम्स के लोन पेयर को एक्सेप्ट नहीं कर सकते, ठीक है. तो इसी कारण से क्या होगा, इसी कारण से हमें यहाँ पे ये जो एनायन है इसका फॉर्मेशन पॉसिबल नहीं हो सकता. सो सो फोर्थ लोन पेयर इज accommodated इन दिस एम्प्टी ऑर्बिटल. मैक्सिमम वैलेंसी कितनी हो सकती है? 4 हो सकती है, जबकि आप BH4 माइनस या फिर BOH4 माइनस में देखते हो उससे ज़्यादा वैलेंसी नहीं बढ़ा सकते हो, ठीक है. तो जो हमारे कंपाउंड फॉर्म हो सकते हैं वो BH4, दैट इज BH3 और H माइनस के इससे बना है. फिर BOH माइनस, OH4 माइनस जो अगेन BOH3 और OH से बना, और BO2 माइनस. सो करेक्ट आंसर इज ए, दैट इज BF6 3 माइनस. मूविंग ऑन टू द नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 4 सेज दैट मार्क द ऑक्साइड विच इज एम्फोटेरिक इन नेचर. है ना. ऑप्शन है आपके A CO2, B SiO2, C SnO2, D CaO. सो आपको पता होना चाहिए कि एम्फोटेरिक ऑक्साइड्स किस कौन बनाता है? मेटालॉइड्स बनाता है, ठीक है. तो आपने अगर मेटालॉइड्स पहचान लिया तो आप इस क्वेश्चन को आसानी से सॉल्व कर सकते हो. सो योर टाइम स्टार्ट्स नाउ टू सॉल्व दिस क्वेश्चन नंबर 4. सो you have 28 seconds. So your time is up. So let us move to the solution part. So we have to decide that which of the given species is forming the amphoteric means oxide. So basically amphoteric oxides are those which have the character of both acids and bases, right? So let us see. So the answer would be SnO2. Okay, SnO2 is amphoteric because it dissolves in acid as well as an alkali. So most of you have looked upon this Si, but that was a wrong answer, right? So your correct answer would be SnO2. So this is the reaction. So this stannous oxide is reacting with your H2SO4 to give SnSO4 whole twice and H2O. At the same time, it can react with the alkali also, which is an NaOH, to give Na2SNO3 and H2O. Moving on to the next question, which is the last question of today's question series. Question number 5. So graphite is a soft, solid lubricant, extremely difficult to melt. The reason for its anomalous behavior is, options are A is an allotropic form of diamond, B has molecular variable molecular masses like polymer, C has carbon atoms arranged in large plates of ring and strongly bonded carbon atom with weak interplate bonds, and D, it is a crystalline substance. So you have 30 seconds to solve this question. Your time starts now. So let us see the solution of this. So graphite is soft. We know that it is soft in nature. You can cut it with a knife also. And what is the reason behind it? Because of the weak interplate bonds, right? Which means they are plates of carbons. So there are layers and layers of carbon to form a graphite. Now the bonding between these two are very very weak and very very fragile, right? Due to that, they are very easy to cut. So it is being written here also that they form large hexagonal layers with weak van der Waals forces between the layers. And you know van der Waals forces are very weak in nature, and as a result of it, it doesn't form this strong kind of structure. So this was all for today's question session. Thank you.